All right, this lesson is going to continue our right triangle trigonometry stuff we've been doing, and it's going to be about angles of elevation and angles of depression. So angles of elevation and depression. And we'll start out real quick with just a definition of both of those. An angle of elevation is an angle above a horizontal line. It sounds kind of simple, but it can get confusing. So an angle of elevation is an angle above a horizontal line. And the key word is above. An angle of depression, as you may have guessed, is an angle that's below a horizontal line. So an angle of depression is an angle below a horizontal line. And again, the key word below. So a quick example of what that would look like here. I'll draw a horizontal line, and then I'll draw one over here. An angle of elevation is going to be formed when you have an angle that is above a horizontal line. It comes off of it like that. It's almost like this red line here raised up off of this black line. And an angle of depression is going to be like this, where it's below the horizontal line. So we can label those real quickly. An angle of elevation will always seem like it opens up like this. So that is an angle of elevation. And an angle of depression will always seem like it opens down like that. So again, angle of depression. So it's not that tough. You just have to make sure that you recognize them and know what they're going to be in word problems. So you want to make sure you get your angles in the right spot. I'll do a little example here. I'm going to draw a quick little picture. Draw an airplane. So here's my super deluxe airplane. And I'm going to have this airplane flying nice and high in the sky, flying above the nice green ground down here. And let's suppose that there is somebody here, a person or a radio tower or satellite, whatever. So let's say you're standing here at this spot and you're looking out like this across the field. Well, you're not going to see the plane. But if you start to look up, and you look up until you see the plane right there, then we've created right here an angle of elevation. Okay, so this is angle of elevation. But just like you are sitting there on the ground looking up at this plane, somebody in that plane is flying along and they're looking out across the nice blue sky. And as they're looking out across the blue sky, they might decide to look down at you. So when they look down at you, well, here they have formed an angle of depression. And we're going to put a lot of things that you've learned this year together into these problems. So it's going to, a lot of things we've done this year are going to kind of come together on these problems in the next few days. So what do you notice about the angle of depression and the angle of elevation? We're going to assume that the plane is flying parallel to the ground. So what do you notice about these two angles? Hopefully you'll notice that they are congruent because they are alternate interior angles that are formed by a transversal intersecting two parallel lines. So that'll come in real handy a little bit later when we're trying to solve these problems. So I'm going to scoot down a little bit and we're going to draw another problem and you need to really probably want to practice drawing these kind of problems, so don't get all frustrated. They're drawing the same picture. Okay, so we're going to draw a plane, and I'm going to tell you that this plane is flying 20 miles above the ground. So the plane, the height of the plane is 20 miles above the ground. So right here, I know this is 20 miles. Now let's say that there's our little radio tower out here, and from the radio tower, the person in the tower looks up at the plane, and he looks up at an angle of elevation of 35 degrees. So let's just draw a picture of what that would look like. He's in the tower here, he's standing down here on the ground, and he looks up at the plane. So his angle of elevation is 35 degrees. Now we want to know what is the horizontal distance from the plane to the tower. So from the plane to, it looks like it says phone, from the plane to the tower. Okay, so that means how long is this? How long is x in this right triangle? Well, when we look at this right triangle, we see that we have 35-degree angle here. We have a 20 that is here, opposite, and we have an x that is adjacent. So if we remember from SOHCAHTOA, we need the opposite and adjacent, so that's t for tangent. So we're going to write tangent 35 equals opposite over adjacent. Now you should be pretty good at these by now, so we want to get rid of that x on the bottom. So we have x times tangent 35 equals 20. We divide both sides by tangent 35. Move down a little bit. These cancel out. And x equals, and then you do 20 divided by tan 35 in your calculator, and you get 28.6 miles. So that was just one little example. Now I'm going to add to this picture. I'm going to do the exact same problem, but I'm going to do it a little bit differently. So, all right, exact same thing. So we have our plane flying along, 20 miles off the ground. Angle of elevation from the ground to the plane is 35 degrees. Well, the plane is flying at a certain altitude. It's flying at 20 miles above the ground, and it's flying straight along, horizontal, parallel to the ground. So what does that mean the angle of depression from the plane down to the ground is? Hopefully you remember it's the same as the angle of elevation from the ground to the plane. It's also 35 degrees. So what does that make this angle right here? Well, 55, because 55 plus 35 is 90. Or you could have done this 35 plus 55 was 90. But either way, it's not very hard to figure out that this angle right here, this angle right here in this problem, is 55 degrees. So if we use the 55, then the x is the opposite, and the 20 is the adjacent. So to do that problem, I would write tan 55 equals opposite x over 20 adjacent. And then hopefully maybe you can see why you might sometimes want to do it differently, do it the second way, because now I just type 20 tan 55 in my calculator and I get 28.6 miles. Just like I got when I did it this way, it's just I did one less step here. So anyways, that's what angles of elevation and angles of depression are. We're going to practice it for a couple of days, so don't worry too much about it. Our pictures are going to get a little more complicated. You might see things where there's somebody standing on a cliff and they're looking out, and there's another cliff, and then they look down at this cliff at a bird nest, and then the birds are looking down at the bottom of this cliff. So we have an angle of depression. The birds could look straight out, so they have an angle of elevation and an angle of depression. And then down on the ground, whatever they're looking at also has an angle of elevation. But don't worry about that today. We'll practice that tomorrow. Write down any questions you have and be ready to talk about this.